All right, so the basic concept of the area of a regular polygon is pretty simple. You see the formula down there, A equals 0.5 times perimeter times apothem. And I've got my basic video for regular polygon area linked in the comments here. But there are a couple of compounding factors that you might see in your geometry class or on the SAT or ACT. One is the special case of the regular hexagon, which you see here. And so this regular hexagon has a side length of 16 centimeters, and of course it has 6 sides because it's a hexagon, but we don't have the length of the apothem, which we'll need in order to find area. Well, we can find the length of the apothem without being given it. And the reason for that is that in a regular hexagon, each interior angle is 120 degrees. And what that means is that this angle here is half of that, which is 60 degrees. And of course, the apothem meets the side length at a right angle. So what we have there is a 30, 60, 90 right triangle, which I'm going to make larger over here. This is our 60, this is our right, and of course this is our 30. And this is what we need here. We need the apothem. So what we do have is this length here, which is half of the given side length. So half of 16 is 8. So if that's 8, then the apothem length, of course, is going to be, we're going to multiply to get multiply by the square root of 3, and the apothem length is going to be 8 times the square root of 3. So we can now plug that information into our formula here. So we can go 0.5 times the perimeter is 16 times 6 sides times the apothem, which is 8 times the square root of 3. And you could solve this one or two ways. You can either multiply everything together with the calculator and include the radical. That version here would be 384 times the square root of 3. Or you can put everything into the calculator, including that, and get a decimal answer, which will be about 665, a little bit more. So you can use the 30, 60, 90 rules to solve that. And I'll also put a refresher of the 30, 60, 90 rules in the comments as well. The other special case here is when we are, again, not given part of this, whether it's a side length or whether in this case it's the apothem, when it's not a regular hexagon. But we can use the same idea plus basic trigonometry to find the missing information that we need. So here we have a regular pentagon with a side length of 12 feet. And we also know that one interior angle is 108 degrees. We got that by doing n minus 2 times 180 divided by n. So what that does, similar fashion here, is that it makes this angle 54 degrees. Now, and we know that this part here, again, it's half the side length, so in this case it is 6, but we still need the apothem. And so here we need to use basic trig. The apothem is acting as the opposite side, and the 6 is acting as the adjacent side of this little right triangle here. So we can find the length of that apothem by making the tangent of a 54-degree angle equal to the opposite side, which is the apothem, over the adjacent side, which is 6. So that's going to become 6 times the tangent of 54. And that makes the apothem, I'm going to put it as 11. It's really like 11.01, but we're just going to use the round number here. So now we have everything we need to find. As I bump this up here, get a little bit more space, we have everything we need to use the area formula. So that's going to be 0.5 times the perimeter, which is 12 times 5 sides, times the apothem length. And if we throw all that into our calculator, we get 330 square feet. Now, if you had the apothem length but didn't know the side length, we could use the same trigonometry to find this little part here, which then we would have to multiply by 2 to get a full side of whatever polygon you're working with. But this not only works with pentagons, it'll work with any number of sides. So I hope this helps. You might find these problems on the SAT or in your geometry class, but I hope you find this helpful. You're working hard. Keep it up. Take care, and thank you for watching.